So in this video we will study about the effusion and diffusion, what are these terms and how we can define. And basically these two terms are based on the movement of the gases, how the gases move from one place to another. That is the defined by the two definition, effusion and diffusion. Effusion means the escape of a molecule of a gas through a tiny hole. So suppose this container have two compartment, and it is separated by a diaphragm, and which have one small hole here. So if one gas is filled completely here, and if we open the small hole, this one, so all the gaseous molecule will effuse. Effuse means they will move or they will escape from this hole into this empty container. So effusion means the escape of a molecule through a gases through a tiny hole. Another example you can understand that if you are studying in the class and 100 students are sitting in the class, so those 100 students we can consider as a gaseous molecule, and when the class is done they all goes from one door. So that is the process of effusion, And the second is a diffusion. Diffusion means a spread of one substance throughout a space or throughout a second substance. For an example, in smoke and air. So in this picture this shows that cube have one molecule. It is showing that one molecule of a gas which is in a random motion, in moving anywhere and everywhere. So a spread of one substance throughout a space, or we can say a spread of one molecule of a or gaseous molecule in a space or through a second substance. So for an example, when we do barbecue, so you may have noticed that all the smoke from the barbecue goes from barbecue container or gases from the furnace container into our atmosphere. So that process is called diffusion process. So these are the two different definition about the effusion and diffusion related to movement of the gases. Next is a little bit more about the effusion. So in this picture this shows that the two gases, this orange balloon have argon gas and blue balloon have helium gas, and both gases effuses through the pores of the balloon, but lighter helium gas effuses faster than the heavier argon gas. So the difference in the rate of the effusion for the helium and nitrogen, for an example, explain why helium balloon would deflate faster. So this shows that argon gas is very heavy, means its molecular weight is very high compared to helium. Helium has only 4 molecular weight compared to argon. So and the effusion rate means all the gases are coming out from the small pores from the balloon. So lighter gas come faster compared to heavy gases. So heavy gases, that is why this balloon did not shrink, did not or deflate compared to helium balloon. So helium balloon is deflate faster than the argon gas. So effusion, the rate of effusion means which gas will come first. So the lighter gases come first than the heavier gases. So this is the effusion rate and diffusion rate. Next is we can understand the effusion and rate of effusion through this graph also, that if there are two gases, so effusion rate of one gas divided by effusion rate of gas number 2 will be equal to under root molecular weight of gas 2 divided by molecular weight of gas 1. So this shows that you can see in this graph the x-axis have molecular speed, meter per second. So basically this is a effusion rate, And here is a, let me just zoom it. So fractions of the molecules. So which fraction is the molecule? Oxygen, oxygen, nitrogen, water, helium and hydrogen. So hydrogen have, you can see hydrogen is lowest in the molecular weight, helium is heavier, water vapor gases are heavier than helium, and then nitrogen and oxygen. Oxygen is the heaviest one in this chart, and this shows that the hydrogen is the lightest one. So the rate of effusion or the molecular speed is higher in all of these. So lighter gas effuses faster because they have more molecular speed than the helium, and the oxygen is the heaviest one in these 5 1 2 3 4 5 oxygen, nitrogen, water and helium and hydrogen. Oxygen is the heaviest one, so that effusion rate is very slow. So we have to compare the two gases, their effusion rate. So we can utilize this formula. Effusion rate of gas 1 divided by effusion rate of gas 2 will be equal to under root molecular weight of molar mass of a gas 2 and molar mass of gas 1. So let's see one example, then we can understand better. The rate of effusion of argon measured to be 0.218 mole per second at a certain temperature. Calculate the rate of effusion of helium gas. So again you can see this question is related to the previous slide where we were comparing the helium and argon. So they are giving that effusion rate of argon is 0.218 mole per second. So effusion rate of argon is given, and we have to calculate the effusion rate of helium. So you can see based on this picture, and we know that the molecular weight of argon is higher, so speed will be slow, and helium rate must be higher than. So helium will effuses much faster rate than 0.218. So let's see how we can calculate this thing. So what to do? So here is this solution. So first we have to write down what is the value is given in this question. So the rate of argon, effusion rate of argon is given 0.218 mole per second, and rate of helium is they are asking. And what is the formula to calculate the, so we will use this one, rate of helium divided by rate of argon is equal to under root molar mass of argon divided by molar mass of helium, and molar mass of argon is 40 gram per mole and molar mass of helium is 4 gram per mole. So this is we know from the periodic table, right? It's it will for argon is around 39.9 something, so we can write for 40 grams. So you can see there is a 10 times helium is lighter, or argon is 10 times heavier than helium gas. So when we will rearrange this formula, so rate of helium will be equal to rate of argon multiplied by under root molar mass of argon divided by molar mass of helium. So now we can replace all these values. 0.218 mole per second multiplied by 40 gram per mole divided by 4 gram per mole. So gram per mole will be cancelled out, and the mole per second will remain. And once we will divide 40 by 4, it will come 10. And when you will calculate under root of 10 in the calculator or from the log table, you will find out this value 3.162, and once you will multiply with this rate, so the answer will come for helium is 0.689 mole per second. So now you can see this helium is 10 times lighter, and the rate of effusion is almost 3 times than the argon gas. So lighter gases effuses faster than the heavier gases. So this was the last slide of this chapter, and I hope you will understand from this video. And if you have any question, just please feel free to write your comment, and then I will try to answer you.